So, good afternoon, everyone, and welcome to this lecture. Here we are, and this is relative motion that we are doing. And I think we had started with relative motion in one dimension. The problem that we did was for rain and man. Yes or no?
Yes, sir.
Just to remind you, I will not tell you what we had done. I will straight away give you a question. Are you ready for it? I just saw a question that appeared in one of the JEEs, JEE Main, I think 2017-18, something of that nature. I just saw it. I thought that instead of giving you a revision, let me just put the question so that you can straight away solve this rather than me talking here and there. So this is the question that comes up. A man, when stands still, so when he's not moving, observes. Remember, every question may have a different language, but at the end of the day, you are supposed to do just one thing and one thing only. The question may be framed in a different way. This question seems to be framed in a different way, but again, you have to do the same thing. A man, when stands still, observes the rain falling vertically, and he walks with a speed of 10 kilometers per hour. He has to hold his umbrella at an angle of 53 degrees from the vertical. Find the velocity of raindrops. So this question is given in a different way. In most of the cases, the velocity of rain is given and you have to find out the angle perhaps. Here in this case, the angle is given and you have to find out the velocity of the rain. I hope you can do this. I'll give you a minute to solve it. Best of lucks.
Tan 53 ఎంత? 1 point something. Exact.
Yes, we have an answer. It seems like
No, sir.
no, sir, or yes, sir.
No, sir.
No, sir. Then find out the answer, sir. No, sir is not an answer, sir. Yes, sir is an answer, sir.
Sir, what is the value of tan 53, sir?
Oh, shameful. Tan 37 is 3 by 4. So tan 53 is 4 by 3. 4 by 3, my dear friends.
The 3.
3 is the answer. That is correct. And how did we get it? I probably have told you that whenever angle is given with the vertical, you don't even have to draw the diagram. The angle is given with the vertical. Yes or no? So you divide horizontal by the vertical. Yes or no?
Yes, sir.
Horizontal velocity would be the velocity of the man. So velocity of man divided by velocity of rain with respect to ground. That will be your tan of 53. Yes or no? Or have I done it wrongly? Have I done it correctly or have I done it wrongly? Yes or no?
Yes, sir.
Now just put the values and get the answer. What is the velocity of rain that you are getting? Velocity of man divided by tan of 53. So you will get the velocity of rain as 3 kilometer per hour. Everyone got this? Yes or no? Any doubts on this?
No, sir.
Okay. These seems to be pretty simple and pretty straightforward questions. Let us move on to the next category of questions. And the next category of question is where we are supposed to solve a question where a person is going to cross a river. We call them river crossing questions. Have you seen those river crossing questions? Yes or no? Have you seen this question? So it is river crossing, or I can call it river boat, or riverman question in 2D. 2D means 2 dimension. How they are in 2D? Well, he's going to cross the river, so he has to go not in the direction or against the direction of flow. He has to move at some angle. Now, what are the things that are normally given in this case, and what are the things that we will have to take our own? So first thing is you will have 1 and 2. You will have a river that will be given to you, and the width of the river will be given to you. Instead of calling it as D, let us call it as W. So W, the width of the river, would be given to you. Do we understand this? River would be flowing, and the direction of river flow, you can obviously take any direction, but here I am going to take it like this. The direction of river flow is like this. I hope it is very clear how the river is flowing. Then the speed of the river or the velocity of the river would be given to you. That velocity of river would be obviously with respect to ground. Do we understand this? So velocity of river, oops, why I'm using this color? I hate using wrong colors. Velocity of river with respect to ground would be given to you vectorly, and it will be, let us take it as u, and let us take the direction like this. So river is flowing like this. Do we understand this?
Yes, sir.
And the velocity of river with respect to ground is u. Now what would be given to you else? Now there will be 2 points across the river. One would be point A, one would be point B, exactly opposite of each other. And this man will start to swim. Now the thing that will be given to you would be the velocity of man with respect to river. Now remember, velocity of man with respect to river would be given to you. It can be given in different ways. It can be said that man can swim in still water with a speed of this. The speed of man in water is this, whatever it is. This would be given to you. And what you were supposed to find out, you would be supposed to find out how much time it takes to cross the river and what is the drift. What do you mean by drift? He may not reach the exact opposite end of the river. He may reach some point ahead or some point behind the river. The distance that he moves along the river and does not reach the point B, that is known as the drift. Do we understand this? Now, in this particular problem, there are 2 particular cases that has to be done. The first and the simplest of them is the case of shortest time. How can he cross the river in the shortest time? Tell me, how can he cross the river in the shortest time? How should he swim? How should he swim so that he crosses the river in the shortest possible time? If you are
Straight
a
line.
swimmer and you want to cross the river in the shortest time, how should you move? With respect to the river, how should you move? It is very simple.
It's a straight line.
What do you mean by straight line? This line is also a straight line. This line is also straight line. This line is also straight line. Which straight line?
Straight line.
Straight
The
line.
displacement should be width of the river.
Not exactly correct. If you don't say something correctly, that means you have not understood it correctly. Talk about these 2 terms. What about VMR and what about VRG? Tell me the direction in terms of these 2 quantities. River is flowing like this horizontally along x-axis. How should the man swim so that he crosses the river in the shortest possible time? Yes. Is it so difficult? The velocity of man with respect to river must be perpendicular to the velocity of river with respect to ground. Do we understand this? In this case, he will cross the river in the shortest possible time. That means if the river is flowing horizontally, this velocity should be like this. Do we understand this? So, to cross the river in the shortest time, he must swim perpendicular to the direction of the flow of river. Are we getting this? Yes or no? No, yes. You understand this, everyone?
Yes, sir.
Now, let us see what happens when he moves like this. So, basically, he starts from point A and he starts to move like this. His velocity is v. He starts to move like this. When he starts to move like this, will he reach the point B or will he reach somewhere else? When he starts like this, the velocity of the river will get added up. Yes or no?
Yes, sir.
And he, instead of reaching the point B, his effective velocity will become something like this, and he will end up somewhere around here. He will end up somewhere around the point C. This distance from B to C is known as x. This x is known as the drift. And why does its velocity become like this? I will just show it to you. Velocity of man with respect to ground will be equal to velocity of man with respect to river plus velocity of river with respect to ground. Did I tell you this? I just put a r in between and velocity of man with respect to river plus velocity of river with respect to ground. Do we understand this? What I've done here? Now, this u is along this direction, so I can call it. I am writing mu. So I can call it ui if I want to write it in the vector form, and v will be written as vj. Do we understand this? So my velocity of man with respect to ground becomes ui plus vj. If I find the magnitude of this velocity, it will be simply equal to under root of u square plus v square. So this velocity, you can easily see this is a right angle triangle, yes or no? So this becomes under root of v square plus u square. Do we understand this, yes or no? We can also find this angle that he makes with the vertical, tan theta, the angle he makes with the vertical, tan theta, the angle he makes with the vertical, and what will be the value of this tan theta?
V by U.
V by u? No. Tan theta. Look at the triangle.
U by V, sir.
U by V. Well done. You can also find other angles. I just want to do it once. So whatever problem comes in whatever way, we should be able to solve this with this one diagram. Can you tell me the value of sine theta?
U by under root V square plus U square.
U by under root of U square plus V square. Well done. Can you tell me the value of cos theta?
V by under root U square plus V square.
Okay. Now, this under root of u square plus v square is basically your velocity of man with respect to ground, yes or no?
Yes, sir.
So you can also write the sine theta or cos theta in this way. You can write the value of sine theta as velocity of river, magnitude, divided by velocity of man with respect to ground? Yes or no? So I can write it like this as well. Magnitude of velocity of man with respect to ground is u divided by sine theta. Yes or no, bacha? If theta is given to you, you can find it out like this, or you can also write it as v divided by cos theta. Are you getting my point, bacha?
Yes, sir.
Okay. These are some of the things that you have to remember. If you remember this diagram, it is all done. But what are the basic questions that they ask? They ask you how much time it takes for this man or this boat to cross the river. Time taken to cross the river. Now, how will I find this time taken to cross the river? Remember, to cross the river, he has to move along y-axis. Yes or no?
Yes, sir.
So he has to move, or his displacement in the y-axis must be equal to w. Yes or no? Yes or no?
Yes, sir.
Displacement along y-axis is w. The only velocity which is along y-axis is v. Yes or no?
Yes, sir.
That is the velocity that is going to help it in crossing the river. Yes or no? So
Yes,
the
sir.
time taken to cross the river would be simple w divided by v. Do we understand this?
Yes, sir.
W divided by v. That will be the time it takes to cross the river in the shortest possible time. Now they can also ask you, what is the drift x? Now how do you find out the drift x? X is the distance it moves along x-axis. X is the distance it moves along x-axis. Only one thing can make it move along x-axis, and that is this velocity. Yes or no?
Yes, sir.
This is the velocity of the river. In whatever time he has moved from A to B, the river has pushed it from B to C. Yes or no?
Yes, sir.
So this x will be equal to the velocity along x-axis, which is u. So this will be equal to u multiplied by t. Do we understand this? So you can remember it like this, u into w by e. If you draw this diagram once, you should be able to do any question that comes in this category using this diagram. Why it is taking the shortest time? Because my entire velocity that I have, I'm using it to cross the river, and I am allowing river to let me drift. I'm not worried about the drift. I'm only worried about crossing the river in the shortest possible time. Do we understand this?
Yes, sir.
Anyone has any doubts? Yes or no? Okay, I'll give you 1 minute to note this down. If you have any doubts, you can raise them up. Else, I will give you a question and try to see if you can solve that question. 2 minutes. Do we have a new admission here? New girl? New girl or old girl?
New girl, sir.
Today, first class, sir.
Yes, sir.
Not understanding anything, sir.
Yes,
Okay.
sir.
It happens. Don't worry. We will be done with the relative motion in this class. From tomorrow onwards, we'll start with Newton laws of motion. and which has got very less to do with this. So it will be a fresh start. And for the topics up till now, what you can do is you can look at the recording lectures and just go through last 2 or 3 lectures, and you can do. Okay. Have you noted down, everyone? X-axis, y-axis, y-axis, x-axis.
Yes, sir.
To move along x-axis, we need velocity along x. To move along y-axis, we need velocity along y. X velocity cannot make us move on y. Y velocity cannot make us move on x. Yes or no?
Yes, sir.
Then, sir, this question for you, sir. And I hope that you understand the question and tell me how this has to be done. A 400-meter wide river. Just draw the diagram first. Do not try to remember all those formulae, because you might not be able to remember all those formulae. Just draw a simple sweet diagram. If you draw it once, the next question you probably can do without the diagram even. A 400-meter wide river is flowing at the rate of 2 meters per second. So what is this 2 meters per second given as?
Velocity of river with ground, sir.
So basically it is, we have used u for this. So they have given the value of u, 400-meter wide. So this is the width of the river, w. A boat is sailing with a velocity of 10 meters per second with respect to water. So this is very clearly given that this is the velocity of boat, not the swimmer. There is no swimmer here. There is a boat here. Boat with respect to the river. And it is also given in a direction which is perpendicular to the river. So you understand which case is this? This is the case of shortest
time.
And the questions then begin. Find the time taken. Question number 1. How far from the point directly opposite does the boat reach? They are asking the value of x. In which direction does the boat actually move with the river flow? So you have to say the direction with the river flow. Remember how we have found out the direction and how they are asking the direction, somewhat different. I'll give you 2 minutes. Think about the question and solve it. 2 minutes. Has anyone done the question?
Yes, sir.
Everyone? Okay, let us first draw the diagram. So I have drawn a rough one for you. AB, 400 meter. Now the gentleman will try to swim perpendicular to it. This velocity is given as 10. I'm not writing the unit. The river, as I've already told you, the river is flowing like this. So what will the river do? The river will take it in this direction. This is 2 meter per second. So effectively his velocity will become like this and he will end up somewhere here. This distance is x. Now you can straight away tell me. I will not write anything more. And they have asked the direction with the direction of river flow, not with the vertical. So they have asked us this angle. Do you understand this?
Yes, sir.
Let us now go ahead and solve this question. All the relevant data is there. Tell me, how do you find the time it takes?
Width of the river by velocity of boat.
400 divided by 10. So he will take 40 seconds to cross the river. Yes or no?
Yes, sir.
Then you can tell me the value of x. There are different ways in which you can tell me. You've already calculated time. You just multiply it by u and you will get, yes or no?
Yes, sir.
U into t. So it will be 2 into t. So it will be equal to 80 meters. Yes or no? Then the value of tan theta. There are different ways. You can tell me this. See, this is theta. This is also theta. Yes or no? So you can tell me by this. This distance is 400. This distance is 80. You can say 400 divided by 80. Yes or no?
Yes,
It's a
sir.
simple geometry question. Or you can do it by this. 10 divided by 2. Whatever way you tell me, tan theta will be coming as 5. Yes or no?
Yes, sir.
Or theta will be coming as tan inverse of 5. This is the case of a body crossing the river in the shortest possible time. What we have to remember is that his velocity has to be perpendicular to the direction of river flow. Everyone understands this? This is a yes, this is a no. Okay, great. Now that is the first case in which I cross the river in the shortest time. What would be the second case? What would be the second case? The second case would be crossing the river in the shortest or traveling the shortest what? Distance. Crossing the river, yes, but crossing it in the minimum possible or shortest distance. So now again I draw the river. I have to draw it every time I do a river boat problem. Okay. Again the same scenario, A, B, and the width of the river is given as W. Again the river, let us say, is flowing in this direction and the speed of the river flow is u, and the speed or velocity with which the man or the boat can swim or can move in still water or river is v. Now the question is, when will you call the case as shortest distance? I told you the case with shortest time would be if he moves perpendicular. When should I say that he has moved the shortest distance? So how should he actually move? No matter how he moves, the shortest distance, if he has to cross the river, will be which distance? He must travel how much distance to move in the shortest distance? He must travel the distance AB. Yes or no?
Yes, sir.
But the problem is, if I start moving towards from A to B, I will not land up at B. I will land up somewhere else. Yes or no?
Yes, sir.
So the next case is, the next question that I'm going to ask is, how should he move? If he moves like this, he does not land up at B. So how should he move? Should he move like this? Should he move like this? Should he move like this? How should he move? So common sense tells us that he should move. There is no physics involved. Common sense, right? He should move like this. Yes or no? Do we understand this?
Yes, sir.
He should move like this. But okay, he should move like this. Then what will happen is the velocity of river should add up in such a way that his total velocity becomes like this. Do we understand this? So that he
sir.
ends up at this point. Yes or no?
Yes, sir.
Now, if you've understood this case, then we see a right angle triangle there. Yes or no?
Yes, sir.
We can find out the value of this side. Yes or no? What will be the value of this side?
V square minus U square.
That means there is a condition involved here. This shortest distance is only possible when V is greater than U. Because if V is not greater than U, V square minus U square will be negative. Yes or no?
Yes, sir.
Or this case is only possible when man's velocity with respect to river is greater than velocity of river with respect to ground. That is why it is said, when it is flooding, you don't try to cross the river. Why? Because no matter what you do, if your velocity is less than the velocity of the river, you will never reach the opposite and the river will throw you away. Do we understand this?
Yes, sir.
This case is only possible when the velocity of the man is greater than the velocity of river. You can also talk about this angle theta, and then you can write all the possible equations from this. Let me write all the possible equations. See, now you can look, this is a right angle triangle again. You can look at the right angle triangle and write a lot of equations. The more the equations you can write, the better you are going to become. Yes or no?
Yes, sir.
So let us start writing. The first equation is velocity of man with respect to river vectorly, no matter how velocity of man with respect to ground. No matter how I write it, it will be velocity of man with respect to river plus velocity of river with respect to ground. Yes or no?
Yes, sir.
Okay. Now I can write this in terms of I and J. Remember, this is my x-axis and this is my y-axis. Yes or no, my dear friends? Yes or no? So I can write this velocity of man with respect to river as minus v. Oops. Velocity of man with respect to river as velocity is like this v. So I break it into components. It will be v cos theta into j minus v sin theta into I. Do we understand this? How I've written this?
Yes, sir.
Plus velocity of river with respect to ground. River is flowing along x-axis, so it will be simply ui. Yes or no? I separate the two terms. So u minus v cos theta times I plus v cos theta j That will be your velocity of man with respect to ground. Yes or no, my dear friends? Oh, I have written something wrongly, I think. This should be sine theta and not cos theta. Do we understand this?
Yes, sir.
Now, if I find the magnitude of this velocity of man with respect to ground, whether you find it from that equation or you find it from the right angle triangle, you will end up with the same thing, v square minus u square. Do we understand this? Do we understand this? Yes or no?
Yes, sir.
You can also write it as v cos theta. You can also write it as v cos theta. Remember, your I component, whatever component you are writing here, your I component should be equal to 0. Why it should be equal to 0? Because it should not drift. Do you understand this?
Yes, sir.
That means from here in this equation, you can also write u is equal to v sine theta. Do we understand this?
Yes, sir.
So basically what we are doing here, bacha, is writing the same equation in different ways so that in whatever ways it come, I can write the value of this sine theta as u by v. From here also we can understand that u should be smaller than v, otherwise the value of sine theta will become greater than 1, which is not possible. Do we understand this?
Yes, sir.
Here again I can write the time taken. Time taken is width of the river divided by the component along y-axis. You can look from whatever. You can write this component in various ways. You can write it as v cos theta. You can write it as w upon vmg. You can write it as w upon root over v square minus u square. Doesn't matter as long as you are writing the same thing in different ways. Do we understand this, or this is going above or it's saying bye bye? Bye bye, I'm going. Then in this case, the drift is definitely 0. The I component is 0. That was the condition. We had to find it out for the shortest distance. And this is what it looks like. Crossing the river in the shortest distance. Not shortest time, but shortest distance. I'll give you 2 minutes to go through this. If you have any doubts, please ask. Have you noted it down, beta?
Done, sir.
Then a very simple question coming for you. Let's see if you can do this question. A man can swim at the rate of 5 kilometers per hour in still water. So basically this is given as your V, velocity of man in water or river. A 1 kilometer, so this is the basically your width, flows at the rate of 3 kilometers per hour. The man wishes to swim across the river directly opposite to the starting point. The first thing that I have to ask you, is it possible for him to reach the opposite end? Is it possible?
Yes, sir.
Why do you think it is possible? Because nothing is impossible. That's why it is possible.
velocity of man is greater than velocity of river flows.
Yes, the velocity of man, the velocity with which he can swim is more than the velocity of the river. Therefore, it is possible for him to cross the river along the shortest path. He can directly reach from point A to point B. Now, the rest of the question is for you. Along what direction must he swim? Remember, whenever they ask you the direction of swimming, they're always asking you with the direction of river flow. They always ask you the direction of swimming with the direction of river flow. So be very careful when you tell me the direction. What should be or what would be his resultant velocity? How much time does it take to cross the river? 3 questions, 3 minutes. Best of luck. Can I help you? I'll give you 2 more minutes. Shall I do it for you?
Yes, sir.
No one could do this?
Time 15 minutes. Sir.
Yes. Time is?
15 minutes.
Time is 15 minutes. That is correct.
Sir, angle 53 degrees.
Angle
53 degrees.
with what?
37, sir.
With what?
Sir,
You have to find, you have to tell me the direction with the river flow, my dear friend.
వీడు చెప్పిండని చెప్పిన.
Okay. So he has to reach the direct opposite end. I've drawn a simple diagram. So how should he move? He should move like this. His velocity is 5 km per hour. Yes or no? Then what would the river do? The river would just add its velocity 3 km per hour and his net velocity should become like this. Yes or no?
Yes, sir.
He will cross the river in the shortest possible time. In which direction must he swim? So let me find out the value of this theta. How much is the value of this theta? Tan of theta can be written as 3 by 5. Yes or no? This implies my theta will be coming as 37 degrees. Do we all understand this? Theta would be coming as 37 degrees. We all understand this? Yes or no? But this is the direction with this vertical. You have to tell me the direction from this because river was flowing like this. So what is the answer now, my dear friend? Direction with river flow. What is the direction with river flow? What is the direction with river? 90 plus 37. So it will be 127 degrees. Do we understand this? Yes or no? In what will be resultant velocity? This velocity is the resultant velocity. Yes or no? So velocity of man with respect to ground, which is the resultant velocity, is nothing but root over 5 square minus 3 square. And the answer is 4 km per hour. Do you understand this? Boys, girls? Yes or no? Then the last part is very simple. How much time does it take to cross the river? So you find out which velocity is along the vertical. There's only one velocity along the vertical, which is the red one. The red one is 4 km per hour. The distance is 1 kilometer. So 1 divided by 4 kilometer, 1 by 4 of hour, which is nothing but equal to 15 minutes, my dear friend. So 15 minutes is your answer for this one. Do we understand this, bacha?
Yes,
Do we
sir.
understand? Do we realize what mistakes or what thing we were doing not correct? Do we understand this? Can I give you one for problem that has both the questions put together? Yes or no? So here is a problem, and I hope that problem does not trouble you. Remember, the first thought that should come to your mind whenever you see a problem is that the problem is simple and that you can do this. If you think that the problem is difficult, you will never be able to do this. This is question number 3. A boat can be rowed at 5 meters per second on still water. It is used to cross a 200-meter wide river from the south bank to the north bank. South, north. The river current has uniform velocity of 3 meters per second along east. Don't worry. So I have to go from south to north directly. In which direction must it be steered to cross the river perpendicular to the current? How long will it take to cross the river in a direction perpendicular to the river flow? In which direction should the boat be steered to cross the river in the minimum time? How far will it drift? So you understand the question, yes or no? 3 minutes you will have, 3 parts, 3 minutes. Best of luck. I think we have an answer. Yes or no?
Yes, sir.
Yes, sir. Then let's start with problem number A, sir. He must cross in such a way that he reaches perpendicular to the current. So it is very simple. I have to move like this. My velocity 5. The river would add up. Its velocity 3. So I'll end up like this and I end up here. And we know this velocity. Yes or no? This is 4 meter per second.
Yes, sir.
We also know this angle, right? 37 degrees. Yes or no?
Yes, sir.
The direction with the river flow is 127 degrees. Yes or no?
Yes, sir.
So theta is 127 degrees, as simple as it gets. If you do a lot of problems, you will find same problems coming again. How long will it take to cross the river? Green problem. Perpendicular to the river flow. Everyone knows this. Yes or no? Let me
Yes,
write
sir.
it in green. T is equal to
3 seconds.
3 seconds.
50, sir.
200 divided by 4. That is 50 seconds. The green one is also done. Let us come to the blue one. In which direction must the boat be steered to cross the river in minimum time?
Perpendicular to river currents.
Yes, it must be steered perpendicular to river. Let us find the time in that case also. Tell me the time in that case. So you will understand which time is more and which time is less. What is the time in that case?
50 seconds, sir. Same.
Huh? Then what's the difference between minimum time, shortest time, and shortest distance? No difference. Shortest time is also shortest distance. Yes. Array, so much time?
40 seconds, sir.
40 seconds, sir. How did you get it, sir?
The velocity is 5 meters per second when we row perpendicular to river currents, and displacement is 200.
Yes, to cross the river in the shortest time, you must go like this. So your 5 meter per second will be perpendicular. So your time will be now 200 divided by 5. This is the maximum, this is the minimum possible time. Do all of us understand this? Yes or no?
Yes, sir.
Then they are asking the drift. How do you find the drift? You multiply the velocity of the river with the time. Velocity of river is 3. Time is 40 seconds. So you get the answer as 120 meters. Do we understand this? Yes or no? No, yes.
Yes, sir.
That's it. That's it about the river boat problems. The most commonly used problems are this. Do we understand them? Okay. Then we'll move on to the last category of problems that we are supposed to do. Those problems are known as what? Wind airplane problems. Wind and airplane problems. Wind airplane problems. Now, these problems are exactly similar to the rain or to the river and boat problems. The only thing is wind has been replaced by, river has been replaced by
Wind.
and boat has been replaced by
Plane.
plane. So in that we had velocity of for boat with respect to river or man with respect to river. Here we have velocity of plane with respect to air. Do we understand this?
Yes, sir.
Here we had velocity of river with respect to ground. Here, let me call it as wind. So because I've written wind there, so I should not use air. I should use wind. Velocity of plane with respect to wind. Here, there we had velocity of river with respect to ground. Here we will have velocity of wind with respect to ground. Do we understand this? Now the plane, even though it is moving in air, it is covering distance with respect to ground. Yes or no? So the same thing that we were doing there, velocity of boat with respect to ground was equal to velocity of boat with respect to river plus velocity of river with respect to ground. The same formula we apply here. Boat is replaced by plane and river is replaced by air. So velocity of plane with respect to ground will be equal to velocity of plane with respect to wind plus velocity of wind with respect to air. The problem here is in boat we were free. We are free in the sense that we just had to cross the river and we were not concerned where we land up. We might land up on point B, we might land up here, we might land up here. But the problem with the plane is once the plane in air and you are in Hyderabad and you want to fly to Mumbai, you don't want to land up at Kolkata because the plane decided to cross that distance in the shortest time and it lands you up in Kolkata rather than in Mumbai. So here what is important is, there what was important was you go in whatever direction, depending on your direction, you will get the minimum time or minimum distance. Here what is important is where you have to land. Yes or no?
Yes, sir.
Else a plane landing in Mumbai will eventually end up in Kolkata. So that is the case and I will not tell you anything about it. I will straight away put you with a question. And let's see who can solve this question. So I will have to frame this question because I could not find it. A plane, let me see what is the velocity of a plane. Okay, a plane can fly with a velocity of 50 meter per second, not that 50 meter per second. It is supposed to go from point A to B. Wind, now the wind will be a lot of wind. Wind is flowing perpendicular to AB with, remember this is an hypothetical question, with 30 meter per second. Plane is moving with 50 and wind is 30. So, the plane will not actually move. The plane will get into an accident. This is just you understand? This is just a question. 30 meter per second. In which direction should the plane move what is the time if distance AB is 2000 meters? So it is very close, 2 kilometers. You have to fly with this plane. It's a baby plane, probably. The question is there for you, my dear friends. Let's see who can solve it for me. I'll give you 5 minutes. If you understand the concept of relative velocity, let's see what you can think about it, and then I'll solve it. Don't worry, this question is exactly same as the question we have already done. Trust me on that. 2 minutes, 5 minutes you have. Best of luck. Remember, the velocity of the plane is given with respect to air. We understand this? Plane only flies in the air. It does not fly on ground, okay? It is not mentioned here. I forgot to mention it, but it is with respect to air or wind or whatever. Do we have an answer, my dear friends? No one?
So time is 40 seconds. Is
Okay.
tan inverse of 3/4.
Okay. Let us see how we are supposed to do this. Answers don't matter, Bacha. What matters is whether you have tried the question or not. So let me just, oops, what has happened? God knows. I will try to make the question in the same way that we had done the previous one. Okay. This is a straight line from A to B. Okay. The plane has to go from A to B. It's always a straight line. I mean, looks like a straight line, is not straight because the earth is a round and sphere and all that. Right now it is motion in one dimension that we are thinking about, right? So My line is not straight. I must correct it then. I did not draw a straight line. Shame on me. Must draw a straight line first. And I think this looks straight. Okay. So he has to go from A to B. Now the problem is, if you go straight away from A to B, he will not land up at B, right? Because wind is flowing. Dong, 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 dong. This is how wind is flowing. Does this remind you of something? Wind flowing like this? Wind flowing like this reminds of this. AB, width of the river. I have to go from A to B. If I go from A to B directly, I will end up in Kolkata. I don't want to go to Kolkata. Do we understand this? Yes or no? Does it remind you?
Yes, sir.
Yes, sir. Then, sir, the question is finished, sir. I should not go from A to B directly because this wind, gentlemen, is flowing like this. Velocity u, velocity u, velocity u, velocity u. And this u, gentlemen, is 30 km per hour. Fictitious question, therefore it is so high. Because I wanted to make the calculations easier. So how should I go, my dear friends, then? Should I go like this or should I go like this? I have to go like this. Do we understand this? The plane has to go like this with 50 meters per second. And then this wind will correct itself with 30 meter per second so that the effective velocity should become like this. And he starts at your place and you land up at the airport that you were supposed to go. Do we understand this? Yes or no? What is this effective velocity which is going vertical? It will be 50 square minus 30 square. That will be 40. Yes or no? Yes or no? So what is this angle? He must move at an angle where tan theta is 3/5. Sorry, sine theta is 3/5. Yes or no? Same, this is same as shortest distance. And how much time will it take to cover the distance? 2000 is the displacement and the velocity which is along the displacement is 40. So it will be 50 seconds. You should end up on the other side with 50 seconds. Do we understand this? This is how questions are framed in a JEE. I'll give you one question on similar lines as homework. Try it at home and tell me if you have done, if you could do this. Same question. I have just asked one path. They're asking 4 paths. That is the only difference. So this is the question for you, my dear friends. As homework, try it at home. And the question is very simple. Find the time an airplane having velocity v tries to fly around a square with side A. Wind is blowing at a velocity u along one of the side of the square. And this is the question. And I'm also giving you the answer so that you don't worry about the answer. The second thing that is given in the dabba is the answer. This is the answer. And as a hint, I will do one more thing. I will give you a diagram as a hint so that I do everything from my side and the rest of the things would be from your side. And I hope that you can solve this question with the hint. The hint is a diagram. and that is on your screens now. So I've given you enough information, which I should not have given, but I want you to solve this on your own. And I don't want to discuss it in the next class, because the next class we are going to start with the next chapter, which is Newton's laws of motion. So as you can see, it is going to move in a square. The wind is blowing from A to B. Tung, tung, tung. He has to go from A to B, then B to C, then C to D, D to A. Remember, it's an airplane. So if he intends to go from A to B, he should go from A to B and not land up at C. Do we understand this now? Yes or no? So with this, we come to an end of this chapter. I've already sent you the PDF of lectures up till now. I hope you have got them. You got them? Yes? No? Okay, I've already sent them. I think yesterday I sent them, entire PDFs of all the questions, of all the lecture that we have done till today. I hope you will get that copy from the office, soft copy, whatever. I'll see you tomorrow, and tomorrow we'll start with the next chapter. Be ready. This chapter, the next chapter may not have much to do with the previous one, because the previous one was all about kinematics, VU. Now A, acceleration and force will come. Take care, and I'll see you in the next class. God bless you all.